Space is vast. It's full of mysteries. We're talking about solar flares and coronal mass ejections, or CMEs, giant bursts of energy from the sun hurtling towards Earth. Could they fry our electronics? End civilization as we know it? Well, hold on to your spacesuits, because we're diving into the science behind these solar outbursts. We'll explore what they are, how they work, and their potential impact on our planet. Now, you might be wondering, why a monkey? Well, in many cultures, monkeys are seen as clever, curious creatures. They're not afraid to explore, to investigate, to get their hands a little dirty in the pursuit of knowledge. We'll be your guides through the cosmos, using humor and easy-to-understand language to break down complex scientific concepts. So, whether you're a seasoned space enthusiast or a curious newcomer, get ready for a wild ride through the cosmos. Alright, space cadets, let's talk about solar flares, those sudden bursts of energy that make the sun look like it's having a major meltdown. Solar flares are like the fireworks of space, fueled by the sun's magnetic field. These magnetic fields move and interact, sometimes snapping and releasing energy. Think of it like a rubber band snapping back with a painful thwap. Solar flares are giant magnetic explosions on the sun's surface. So what exactly happens during a solar flare? Let's break it down. First, you've got the buildup of magnetic energy in the sun's atmosphere. Then bam, the magnetic field lines break, and all that pent-up energy is released in a sudden, explosive burst. Now that we know how solar flares work, let's talk about how scientists classify these fiery outbursts. We rely on a system based on their X-ray brightness, as observed by satellites orbiting Earth. At the bottom of the class, we have the A-class flares, the underachievers of the solar flare world. Moving up the ladder, we have the B-class and C-class flares, which are a bit more energetic but still relatively mild. Things start to get more interesting with the M-class flares, but the real heavyweights of the solar flare world are the X-class flares. Alright, space fans, we've talked about solar flares, those bursts of energy that make the sun look like a strobe light at a cosmic rave. But now, get ready for something even more impressive, more massive, more likely to make you say, "Whoa, the sun did." I'm talking about coronal mass ejections, or CMEs for short. Imagine this: 1 billion tons of superheated gas, a roiling, magnetically charged cloud of plasma, blasting off the sun's surface and hurtling through space at millions of miles per hour. Unlike solar flares, which are primarily about radiation, CMEs are about stuff, specifically plasma. Now, I know what you're thinking. Aren't solar flares and CMEs basically the same thing? Both involve the sun getting a little feisty, right? Well, yes and no, they're related, kind of like cousins who show up to the same family reunion and cause a ruckus. But they're distinct phenomena with their own unique characteristics. Think of it this way. A solar flare is like a flash of lightning, a sudden intense burst of energy that's over relatively quickly. A CME, on the other hand, is more like a cannonball, a massive, slow-moving projectile. When a solar flare and a CME occur together, it's like watching a cosmic ballet, a delicate and dangerous dance of energy and matter. The flare, with its burst of radiation, acts as the opening act, setting the stage for the main event. Then, the CME, a swirling, churning mass of plasma, takes center stage. Alright, space cadets, we've talked about solar flares and CMEs, those bursts of energy and plasma that make the sun look like it's having a cosmic temper tantrum. But now, let's bring things a little closer to home. What happens when these solar storms reach our little blue planet? Earth is surrounded by a protective magnetic field, kind of like a giant force field that shields us from the worst of the sun's fury. Most of the time, this magnetic field does a stellar job of deflecting solar particles, keeping us safe and sound. But when a particularly strong solar flare or CME comes along, it can cause quite a stir in our cosmic neighborhood. One of the most beautiful side effects of geomagnetic storms is the appearance of auroras, those shimmering, dancing curtains of light that grace the skies near Earth's poles. You might know them as the northern lights, Aurora borealis, or the southern lights, Aurora australis. When those charged particles from the sun slam into Earth's magnetic field, they get channeled towards the poles. There, they collide with atoms in our atmosphere, oxygen, nitrogen, and other gases. And these collisions excite the atoms, causing them to glow. The result is a dazzling display of light and color that has captivated humans for centuries.
They say it's chaos, a world undone, but
Not all effects of solar activity are disruptive. In fact, one of the most breathtaking consequences is the creation of auroras, also known as the northern and southern lights. These shimmering curtains of color are caused when charged particles from the sun collide with gases in Earth's atmosphere, exciting them and producing light. Why auroras are magical colors? Different gases produce a variety of hues. Oxygen gives green and red, while nitrogen creates blue and purple. Global appeal. While most visible near the poles, powerful geomagnetic storms can make auroras visible farther south, treating millions to a natural light show. Cultural significance. Throughout history, auroras have inspired myths, art, and wonder, serving as a reminder of our connection to the cosmos. So while solar flares and CMEs may seem intimidating, they also gift us with one of nature's most stunning displays. Proof that beauty often accompanies power. While auroras might be the most visually stunning effect of geomagnetic storms, they're not the only one. These cosmic disturbances can also wreak havoc on our technology-dependent world, disrupting everything from satellites to power grids. One of the biggest concerns is the impact on satellites, those artificial moons that orbit Earth and provide us with everything from GPS navigation to communication and weather forecasting. When a geomagnetic storm hits, the surge of charged particles can interfere with satellite signals, causing disruptions and even damage to sensitive electronics.
it paints the skies, it gives us life, yet fills my heart with awe and strife.
Now, you might be thinking, okay, that sounds bad, but how likely is it that a really powerful solar storm could cause widespread chaos? Well, to answer that, let's take a trip back in time to 1859, when the most powerful geomagnetic storm ever recorded, the Carrington event, rocked our planet. Imagine this. It's September 1st, 1859, and amateur astronomer Richard Carrington is observing the sun from his private observatory in England. Suddenly, he witnesses a blinding flash of light, a massive solar flare erupting from the sun's surface. Within hours, a powerful CME unleashed by the flare slammed into Earth's magnetic field, triggering a geomagnetic storm of unprecedented intensity. Auroras, so bright they cast shadows, were visible as far south as the Caribbean. The Carrington event, a cosmic close call. Let's rewind the cosmic clock to 1859. Picture a world without smartphones or the internet. Gas lamps lit the night, and the telegraph was cutting edge. It was a simpler time, but not without surprises. Enter the Carrington event, a powerful solar storm. This wasn't just a vibrant Northern Lights show. It was a cosmic tantrum, a solar flex. On September 1st, 1859, Richard Carrington observed a blinding white flash. This was a solar flare of extraordinary magnitude. Unbeknownst to Carrington, a coronal mass ejection was heading towards Earth. Within 17 hours, it would crash into our planet's magnetic field. Section 2 Telegraph. Chaos, when sparks flew. As the CME hit Earth's magnetic field, it triggered an intense geomagnetic storm. Auroras blazed as far south as Cuba and Hawaii. People read newspapers by the eerie green light, mistaking it for dawn. The real drama was technological. The telegraph went haywire. Operators faced sparks and flames. Telegraph poles threw off sparks, lighting up the night. Some operators used geomagnetic currents to keep lines running, making the best of cosmic chaos. The Carrington event showed solar storms' impact on technology. Imagine the chaos today, with our reliance on satellites and power grids. Section 3. A glimpse into vulnerability. Lessons from Carrington. The Carrington event reminds us of our planet's connection to the sun and the vulnerability of our technology. A similar event today could cause widespread blackouts and disrupt communication networks. The economic impact could be staggering, costing trillions and disrupting global supply chains. Scientists are working to improve space weather forecasting and protect our infrastructure. The Carrington event serves as a valuable lesson in our technologically advanced age. Cosmic preparedness. We've got this, mostly. Okay, I know what you're thinking. Monkey, you've just spent the last few sections scaring us silly with tales of solar flares and CMEs. Are you telling me we're just supposed to shrug our shoulders and hope for the best? Well, calm down, my anxious primate pals. While a Carrington-level event could throw a wrench into our technological gears, we're not defenseless. Humanity has a knack for adapting and overcoming challenges. We've been doing it since we started walking upright. And while our ancestors looked to the skies with awe, we've got science. We've learned a lot about the sun and its outbursts. We've built satellites that monitor the sun 24/7. And we've developed technologies to harden our power grids and communication systems. So, while a major solar storm could cause disruptions, it's not going to send us back to the Stone Age. We're not helpless primates cowering in caves. We're a species with the ingenuity and resilience to face cosmic challenges head-on. And who doesn't love a good excuse to dust off those old board games and enjoy some quality time with loved ones by candlelight? Space weather forecast. Keeping an eye on the sun. Remember those weather apps on your phone? The ones that tell you when to pack an umbrella or grab a sweater? Scientists are getting good at predicting space weather too. Think of it as a cosmic forecast. NASA and NOAA have spacecraft monitoring the sun. These cosmic sentinels track sunspots, flares, and CMEs, providing constant data about our star's activity. Scientists use this data to create space weather forecasts, giving us a heads up about potential geomagnetic storms. This helps protect our critical infrastructure. Predicting solar storms is like predicting earthquakes. We know they'll happen, but specifics are tricky. With each solar cycle, our forecasts improve. Embrace the cosmic show, don't fear it. So, there you have it, fellow space explorers. We've journeyed from the sun's core to Earth's magnetic field, understanding solar flares and CMEs. The sun, our life-giving star, can throw epic tantrums, flinging energy and plasma our way. But humanity has developed impressive tools to weather these solar storms. Satellites monitor the sun, scientists analyze data, and engineers design systems to withstand solar outbursts. It's like a cosmic game of chess, with humanity staying one step ahead of the sun's fiery gambits. So the next time you hear about a solar flare, remember, knowledge is power. The universe is vast and wondrous, full of mysteries to unravel. And honestly, a little solar flare just adds to the excitement, right? Keep looking up with curiosity, not fear. As we wrap up our cosmic adventure, let's appreciate the bigger picture. The sun's flares remind us of the incredible forces in our universe. We're part of something grander, a cosmic dance of energy and time. Embrace the unknown with curiosity and a thirst for knowledge. Continue exploring space, pushing science's boundaries and marveling at the cosmos. There's still so much more to discover. Who knows what other secrets the sun holds? The journey of exploration is never over. It's a constant process of discovery. Keep looking up, asking questions, and never lose your sense of wonder. The universe is vast, mysterious, and full of surprises, making exploration exciting. Catching a glimpse of a solar flare or CME is a bonus, reminding us we're part of something extraordinary. So that's why I fear the sun. It's a fiery giant full of surprises. If you enjoyed this cosmic adventure, like the video, subscribe to the channel, turn on notification, share the video and comment below. Thanks for watching and stay curious.